Thank you everyone for joining us today. Appreciate you taking the time. I'm going to jump right in and introduce today's speakers. So we have Charlie Nobles with us today. Charlie leads TerraGo sales across our utilities and smart infrastructure. You bring, of course, a lot of deep experience in AMI, smart grid modernization, connected lighting from his roles at Ubiquia, Census, and Duke Energy. Jeremy Farrow oversees operations at TerraGo. More than 20 years of experience at NextEra, including large-scale grid and infrastructure programs. Dave Reef will be doing a demonstration for us today. Senior Director of our services, he leads TerraGo's services work with many of our leading and strategic city and utility customers, helping deliver, street light, grid modernization, asset management solutions, including CPS Energy's award-winning command center platform, relevant to today's conversation. Before we get started, I would like to remind everyone or tell everyone, we will send out these slides to everybody that attends. So if that's helpful for considering notes or things like that, please know that we will send those out as well as a recording of today's session. We also, at the end of the session, I'll have a QR code. If you want to book a personal appointment so we can customize a demo and a solution and a briefing based on some use case or question you might have, please know that we'll have that available as well. You'll be able to book a meeting as well. And of course, while we're going, please feel free to ask any questions. At the end, we will have a Q&A session. So ask us anything, put us to the test, put our experts to the test, and let's enjoy and get the most value out of this time together. I will start, and I will turn things over to Jeremy Farrell.
All right. Thank you, Mike. And thank you, everyone, for attending today. Hopefully, we provide you with some informative information, kind of raise some questions and thoughts in your mind. Looking forward to seeing those at the end. Really just kind of wanted to start out with TerraGo as an overall, right? Who is TerraGo? Effectively, TerraGo was founded in 2005. And has spent nearly two decades really helping organizations manage large-scale infrastructure and field operations. We definitely support very infrastructure intensive and heavy industries, such as utilities, who are our primary customer at this point. And really where, teams must coordinate people, assets, and systems across wide geographies, we feel fill a good void. Currently, TerraGo is supporting more than 2,000 customers over 70 plus countries and all 50 US states, managing millions and millions of assets throughout the infrastructure globally. With that background, I really kind of wanted to talk a little bit about, TerraGo as a utility operations platform, right? So a lot of folks on the phone probably certainly know us as a street light operations platform, of which we have become industry leaders, experts in that market. But realistically, the platform that TerraGo has is utilized for utility operations overall. And Mike, you can go forward to the next slide, please. Really, the TerraGo advantage is really operationalizing data for utility operations, right? So, it's certainly the area where we've had a lot of success with a number of folks on the phone. The comprehensive utility platform is really at the core of what we do. And we take information from, assets, sensors, field crews, enterprise systems, and really turn it into actionable operations. Realistically, that means that utilities get to track assets, manage inventory, understand crew productivity, and reduce kind of the general noise that's out there with all the data that's coming across your systems. Critically, a big piece of what we're doing is, really keeping data synchronized across systems so field teams and operational staff really can all operate from the same source of information, right? Improving coordination and decision making. Another key component that I want to point out is really our no-code platform, which is what allows our platform to be extremely flexible. What does that mean? Extremely flexible, meaning customizable, meaning we can pinpoint to the individual customer what the needs are and build the system around those specific needs. Mike, you can go for it, please. So what we're showing here is really, TerraGo obviously at the center, which is, a unified environment for, as I said, managing infrastructure assets, and field service execution and really workforce coordination. Um, I'm sure everyone on the phone understands, right? Utilities, companies, et cetera, often manage these functions in disparate systems across a lot of disconnected tools. And Terrio really consolidates those into one platform, right? Antenna is not to replace the system; it is a supplement to the system to bring everything into kind of that single pane of glass for operational efficiency. Obviously, we'll talk about some core capabilities of throughout this webinar, including things like asset tracking and mapping and work orders and scheduling and dispatch and et cetera, et cetera. But the fundamental piece to really pick up on is really the outcome of all of this together, is that it's real-time operational visibility and tighter coordination for you across teams. So work is executed better, faster, more efficient, lower O&M, and certainly with fewer surprises and less rework. Mike, you can go to the next one. So how do we do this, right? We've talked a lot of about a different we've talked a lot of different stakeholders, et cetera. What this slide shows, and we realize this is a very busy slide, but it is fundamental. What this really shows is how TerraGo connects people, the field operations, the enterprise systems, and including the smart infrastructure into really one single operational environment. Certainly at the center, obviously, is TerraGo and the operations platform, delivered via web and mobile apps, a number of analytics dashboard. Really, again, so every role has access to the same operational picture. Um, the platform includes operational models, such as, again, asset tracking, inventory management, work orders, coordination, scheduling, dispatch, short and long-term cycle workflows, et cetera. Below that is really the integration layer that enables TerraGo to kind of connect with the existing enterprise systems within your portfolio, such as GIS, outage management systems, meter data management systems. We do that through APIs and commercial connectors that we own and run. And really, TerraGo can integrate with all those smart infrastructure and sensors, such as, grid sensors, transformer monitors, lighting controls, and then quite frankly, meter types, right? And again, bringing real-time field and device data directly into the operational workflows. You know, at the end of the day, really, TerraGo can really become an operational hub, single pane of glass, to help the utilities when they're synchronizing the data across their systems and make sure everybody's working from the same starting point. So with that, I will actually turn it over to Charlie to delve a little more into the specific meter components of it, but wanted to at least outline kind of the general components of TerraGo for you. So thank you.
Thank you, Jeremy. And we'll just keep this slide up just for a second. I think Jeremy made all the key points about the way we've laid this out. This is a lightweight platform. It kind of sits on top of the systems of record that you have, the devices in the field, addresses all the different constituents on the top row that you've seen and Jeremy referenced. And it's intended to focus on operational efficiency from meter operations. So we're going to talk primarily about meter operations today. It doesn't replace the back office systems, as Jeremy said, but it really addresses the issue about how do you get the right data from all these systems into one pane of glass in a way that can make operationalizing this data succinct and actionable and push it into workflows that are efficient. Key areas we're looking at is inefficiencies, pain points, manual processes, time lags between data that flows into and out of different systems so that that time lag represents an opportunity for failures like a handoff in football. It's every time you hand off, that's a fumble opportunity. And then couple that with one thing I want to mention from this slide was a true mobile platform. We have the web internal web platform with analytics dashboards, but notice in this image that we have distilled down to the mobile hardened native applications in the field. So the crews in the field have access to what you want them to see in order to drive operational efficiency. In the next few slides, we're going to just pick out a few areas to show what we do in these areas and how we can help you with the existing data flows and streamline them, add intelligence, add context to drive operational efficiencies. This is not replacing any of your systems. It's trying to make them more operationally efficient and lower cost of O&M in doing so. So let's move to the next slide. This is a bit of a provocative statement. Your meters are talking. Are you listening? Are you hearing what they have to say? There's so much data generated by the devices in the field that go beyond just generating the billing determinants. Data is captured in multiple systems. The question is, are you able to take advantage of this data to improve operations? We're focused on operational workflows in our platform. Much of the raw data doesn't have context or metadata to give you some sense of what to compare it with, what you should do with this data. We're going to offer key capabilities of the platform to take this data and put it in a way that you can operationalize it. It's kind of like listening to a lot of conversations in a crowded room, and you're trying to pick out different conversations. Imagine that we have a way that we can take these different conversations, the bits and pieces, and render to you what you really need to hear with intelligence. You can identify what conversations matter to drive operational efficiency, and eventually the push is to reduce O&M cost of your current meter operations. Let's go to the next slide here, please. So as we look across MDMs and multiple head-end systems and multiple devices that's been deployed on the meter side, the MDM platforms have evolved to where they can handle multiple head-end systems. And they can be used to manage both the legacy meter operations and the new AMI 2.0 installations you might be having. And so you always will have a mix of asset types, even amongst just the meters. You have C&I meters, residential meters, different types of commercial industrial meters. You have legacy meters not yet improved or changed out in the field. As an example, and again, I'm not going to speak to every point on every slide. You have access to the slides later. But just on the C&I side, imagine that you can take these voltage anomalies, poor power factor customers, and you can prioritize them with intelligence according to your business logic. So you can identify which of these voltage events are suspect to power quality. And then imagine you could sort those and prioritize that by power factor, by customer type, by location, by multiple, which shows you which of the customers are using more of your power, and thus you have more lost revenue that you can recover. This is an example of the kinds of things we can do to take the data you already have, but we can make it more actionable. Let's try the next slide, please. Now, we're not going to talk about all of these. We're going to touch on many of these, though, and you might have additional questions. Hopefully, questions are coming up in your mind as we talk to these slides. But imagine in these different areas, and these are not all of the areas that you have pain points in. But imagine that we could not replace your systems, but we could help you optimize your operational workflows in each of these areas and do them in parallel, not in series, not in silos. Your systems have all this data. We're trying to help you target work orders, dispatch workflows to address and improve these different areas. We're going to take each of these a bit in turn and just talk just a minute or two about each one of these areas that you see here listed. So Mike, if you could catch the next slide, please. So a smart meter operations center. Now, many utilities, when you do large rollouts, you may be looking at the need for a smart meter NOC, or Operations Center. And we have been working with utilities in this area as well. This is a case where large deployments are underway, and you're trying to have a pane of glass that can capture the relevant data between the systems, between the work in the field, and drive this deployment strategy. At the same time, optimize your field operations. Look at your asset lifecycle management. If you have meters or devices that need to be attrited out or have a scheduled maintenance interval. So imagine looking at each of these areas, but instead of doing them in silos, that you could somehow do them in parallel with the right crews to the right areas and work these workflows in parallel. That's kind of one of the key deliverables that we have been shown to provide to our utility customers, which really drives savings and efficiencies and reduces time to maintain any of these operational elements in your back office. Let's try the next slide, please. So let's just look a little bit at the head-end solutions, at the MDMS, the head-end systems, ADMS. So we're trying to take the right data to distill down the few areas that you need to focus on. There's so much noise coming from all these systems, and data is flowing through these systems in two directions often. So imagine taking the insights, the data flows, and you can initiate the specific work orders, dispatching the right crews to the right areas, and update your work order data, update your asset data in a way that is not batched. Why batch these data flows or update systems of record after the fact? Imagine having hourly, daily updates on the outcomes of all of your field workflows, and all reflected in the proper back office systems as they occur in the field, not afterwards with batch processes. Let's try the next slide, please. And this is a key slide. It's one of my favorite slides because this represents part of the problem and the challenges that many utilities have. Utilities are drowning in data and suffering data fatigue. And we often hear the same question. We have all these inputs, all this data flowing through. And in the day, an operational manager is asking the key question, can you just tell me what data I need to address right now? Can you distill it down to a work order? Do I have a work order to complete? And where would that be? And what do I need to do when I get there? So if you can distill it down to the right of the funnel, to the select few areas that you need to drive qualified work orders and dispatch from all the noise, the data input, some of which is important, but it's not vital to today's operations. That's where we're acting as an intelligent filter between the raw hardware data, the other data from different disparate systems, to actual field operations. We're trying to create the work orders, push this into existing work order systems, or we can actually create the work orders and drive them through routing and dispatch to your crews directly, and then update your work order system of record after the work is being done. We can do this either way on the right side. That by doing this, we have found that we can significantly reduce duplicate truck rolls, unnecessary truck rolls where there's no trouble found. Anecdotally, I'll tell you that with the business logic that the utility provides to us and how they want to handle each of these data inputs, these alarms, these alerts, these notifications, we've been seeing at least a 4-to-1 drop in alerts on the left to issues on the right. And then a further reduction from these are the known issues, which of these issues are prioritized that should be sent out immediately for work orders. So at least a 4-to-1. In some cases with some of our customers, it's actually a multiple of 100-to-1. Imagine running trucks for every alert and every alarm. You just can't afford to do that. What you need is some distillation of the true prioritized, qualified work orders, issues that need to be conducted at the right location, with the right gear, at the right cause of the problem. That's really where this approach, which we use your own business rules to come up with the criteria to push these data alerts and alarms through or pull them out. While still archiving, every piece of data is still archived. Nothing's lost, nothing's overlooked, but we're trying to drive out operational savings on the far right end of this slide. So this is a slide that I think is one of the most important, powerful features that our lightweight platform can render to utilities to drive operational savings. Next slide, please, Mike. Hopefully, you're reading these slides, you're thinking through some of what I'm saying, what Jeremy's mentioned. You'll see the demo later, and you are coming up with questions, specific questions. We're talking fairly high level. We don't have the time to go into each of these areas that we address, but please be thinking through your pain points, your challenges, and send us back some questions that we can answer in particular. Let's move to asset lifecycle management. You know, existing asset management systems and platforms for utilities, if you go back far enough, they were originally architected for centralized, plant-based, fixed assets. But the utility architecture is nothing like that today. There are disparate systems and disparate sources of data. It's distributed out in the field as we push grid intelligence to the edge. That creates complexity. And you need to look at your asset management and asset lifecycle management in terms of mobile devices, distributed assets. Our platform amplifies the effectiveness of these new asset types by merging the geospatial information that we have on location and type and context and push through native mobile platforms for field crews, focused on the operational flows that are needed to support asset health in the field. So by detecting anomalies, alerts, defects, implementing work schedules, which could be schedule-based or they could be criteria or condition-based, we can drive an improvement in the total lifecycle management of any asset you have. And I'm focusing primarily on meters today. So eventually, when the crew is in front of the real asset in the field, that is a moment of field asset truth that has been captured. And sometimes the asset truth is captured by a third-party contractor. It doesn't have the context of your broader operational flow. And that truth through our platform can be combined with and merged with what you think is out in the field and the condition you think the asset has to update, repair, fix, maintain, and then update back office systems. So at the end, you are always maintaining an accurate truth of what the true criteria in the field, the true condition of the asset is in the field. This is extremely important as the number of assets you manage as utilities is in the millions. Next slide, please. This is one that we tend to gravitate to in this day of going from AMI 1.0, well, from AMR to AMI, now to AMI 2.0, which has so much more capability in the field at the edge. And the question is oftentimes, how fast can I deploy? The trick here is that when you get in the field with field crews, you will see exceptions and you'll see conditions that are not at all what you thought they were when you send crews out. And oftentimes deployment of new meters is done by contractors that show up on site, and they might or might not have the equipment they need. They may run into a meter base that's pulled away from the structure, has to be repaired before a new meter can be installed. Do you have the flexibility to capture that change in the work order so that the work can be done, or to, in the field, when you see that, enable the crews through a tool that can dispatch a different crew type that could fix, repair, remediate that site so that a new meter can be deployed? Can you capture that in a way that is more of a parallel operation rather than a series operation? This idea of real-time exception management built into the configurable workflows, it keeps the project and task on hand and on time, and also maximizes the productivity of your crews in the field as they track, and you're measuring the productivity of those crews at the same time. That seems like those are mutually exclusive. The truth is, with the right integration of field data, field truth, with what you have in your GIS systems, your other systems of record, and updating that in real time, that's really the only way you can maintain deployment acceleration and handle these exceptions that you will invariably run into. Let's try the next slide, Mike, please. I'm touching on the hot spots here. I want to leave time for the demo. I want to leave time for your excellent questions I expect you'll be bringing back. So let's talk about field operations. Is field deployment of new meters and field operations of all of your assets, are they mutually exclusive? Do they require different crew types? Are they done in series or in parallel? Are they siloed? One of the ways that our platform has shown a lot of value to utilities is by moving things from series and silos into concurrent operations in parallel. That's easier said than done, but requires a flexible access to the data and a platform that can drive those changes in real time. In the area of just field operations and optimizing that, prioritize the exceptions you see in real time and directly incorporating that into intelligent trouble ticket routing and completion is critical. Imagine your crews being on site with a simple mobile app which has instructions that they need to follow to complete a work order, but then they see new field truth, which they invariably will. Can they pull up the customer premise work history to give them some context as to when was the last time this was seen? What was the condition? What was the last piece of work done at this customer premise? That's one of the key attributes of our mobile application is the ability to pull up true premise work history as it informs the work that's got to be done, or if a work order change has to be made on site by the crew when they're standing right in front of true field truth. Let's go to the next slide, please. So let's talk about outage intelligence. Typically, there are systems in place today that can capture outages. The meters can capture outage information, push that up, and you can schedule and address outages, or you can find out where the opening point is for the outage. Is it at the premise? Is it further upstream at the transformer? Is it at a relay or a fuse? And you have systems to do that. One of the areas that we focus in is using these multiple data feeds, excuse me, to identify and cluster these. When you begin to cluster in real time these different types of grid edge issues, sometimes you can see trends that you would not see if you were working them one at a time or working them in series. And that clustering combined with other data we have access to that are in your systems today can inform some more intelligent decisions around what the true cause is. Where is the cause the greatest, the issues are the greatest to be remediated? This includes power quality visibility, but it also includes the ability to look across different meter types as well to see if there's something here more than just that meter is showing an outage. Is there something else that needs to be considered to properly dispatch the crew to the right place with the right equipment on board so that when they get there, they're at the right location and they can work the trouble ticket and do restoration in a more efficient way. This is not trivial. And the truth is, if you look at alarms and alerts, let's just take momentaries. If you detect momentaries at the meter, you could have caused a momentary by some type of operation upstream, or a voltage anomaly, which really could have been caused by a capacitor bank upstream to provide voltage support, has nothing to do with the meter, the endpoint. So moving and rolling the truck to that endpoint to see why there was a voltage sag or a momentary, that could have been a recloser operation. So the issue is not the meter, the issue is upstream. Capturing that in real time, validating it with other pieces of data that you already have access to, provide that context. That's where the clustering really creates a lot of benefit in knowing where the most high value work is in restoration, and by knowing that intelligence. It's not easy. It's kind of blocking and tackling, but do your teams, do your crews, do your resources have the time to investigate that before you start sending crews out to do work, sometimes they'll go and they'll see nothing, no trouble found because they're not at the right location. They don't have this more spatial view of the true heat map of where these issues are biggest, and are they all the same issue or similar issues. So that's a key area of using this heat map approach to streamline the failure patterns, which tells us true cause of failure, location, and then what to put on the truck to take with you when you send a truck out. Let's try the next slide, Mike. This is an area much like the distributed resources, distributed generation, behind the meter activities that you may or may not have visibility to. This is an area where utilities are often struggling because each of these asset types oftentimes can require a different crew type with different skill sets to address. If you send a crew out to take care of a line sensor issue or asset, that's very different than a transformer, very different than other grid sensors, certainly very different than smart meters. But an issue at any one of these assets will inform and could drive alerts and alarms at the other locations as well. Do you do these in silos, or do you have common crews that have broader skill sets? Would that be a benefit? So imagine having one platform, our lightweight platform, that can see across your different disparate asset types and orchestrate the interrelated workflows. It could be where routing of one crew to take care of one asset class could also take care of the other in the same area if they knew it was an issue and they had what they needed on the truck to do the remediation. Or do you dispatch a separate crew? And even in dispatch, which is the closest crew? What operations center do you drive them out of? Which crews have the bandwidth to handle that issue? Which of these issues has more impact on customer satisfaction or outages? This is another area where by looking across the enterprise and pulling the correct data, applying your business rules, we can give you a holistic view of how to better manage the operational workflows for different asset types that you have versus siloing them with different crews, which might be passing each other on the street to go to two different asset types on the same street, and one crew might do the work for both. I've given you a lot of things in about 10 minutes here to consider and look at, and some of this is high level, but what we're going to transition over now to is a demo that could kind of put shoe leather wrapped around this a bit and show you a bit more of how we do some of these things in a way that might be more tangible and help you kind of envision what's possible with a platform like ours that lays on top, that takes data from disparate sources in your back office and the devices, applies your business logic, and streamlines your operational workflows. So I'm going to transition over to Dave Reef, and Dave is going to set up a systems demo. And then after the demo, we'll roll back over to Mike, who will introduce opportunities for you to ask questions, and we'll try to give you answers. Mr. Reef, you're on mute. There you go.
Thanks, Charlie. So we are going to walk through a quick demo of just some of the capabilities of TerraGo system and how it can help you with your meter operations. And I know, like Charlie and Jeremy have already mentioned, we're going to keep this kind of at a higher level just to give you an understanding of TerraGo's platform. And if you want to have more detailed conversations, please reach out to us and we can set those up. So what you're seeing here is TerraGo's application. So our application comes into two major parts. One is our web application, which is what you're seeing on the left side of the screen here. This is really intended for back office users who are at a desk reviewing work, reviewing information coming off the meters, scheduling work orders for crews, things like that. On the right side of our screen, this is my iPhone displaying our mobile application. The mobile application has access to all of the same data that our web application does, but what we do in the mobile application is try to streamline and operationalize that data into workflows that really make sense for field crews. So we try to filter out as much of the noise as we can that's available for back office expert users to see on the web and make sure that the field crews are really just seeing information that's pertinent to their day-to-day jobs. So one of the main things we do in TerraGo is we try to store all the information you need around the assets that are in the field. So we're not just displaying the information coming off your meters, we're tying that back into your asset data that comes from your back office systems. So what you can see here on the map is I'm displaying not just the locations of where the meters are and the houses they're tied to, but we're actually displaying all the other information around the conduit and the circuits that are feeding those. So here at the top of the street, I can see there's a transformer, and then I can see all of the poles it's feeding and the meters that are getting fed from those locations as well. So um, in the field, when crews are out there, they can actually see, okay, if I'm having an issue on one of these locations, I can follow it directly on my map all the way back up to where it's being fed and try to find potentially where the real source of the problem. And all of this on our mobile applications is tied to our location. So this is just some test data I've created around my house, but as you can see here, this is actually where I'm sitting at my desk right now. So when I'm in the field, I'm actually able to see where I am relative to all the information I'm interacting with. So one of the things we try to do is make sure that this information is relevant to the work you're trying to do. What you'll see I have here displayed are the actual locations of the meters. So what we're doing is we're tying that information from your asset management and GIS systems around, right, what are these actual meter sites here? So if these are houses, we can do things where we allow you to assign impact scores to them. So what I've done is just assign different relative weights to these different houses. So now that we have information around kind of the impact of all these different sites, we have the information coming off the meters, so I can see the information coming around off them on voltage and current magnitudes, power factors, things like that. We can use that information to then make decisions on how you want to prioritize work. So if we have information on, for instance, say we have an extremely high impact site that has an impact of a 9 score, we may actually want to roll a truck to this one first rather than say one that's having a critical issue that's an impact of 2, depending on how that affects your operation. So those are the kind of things we can do now that we're tying those two data sets together. But we still have all the information around what the kind of traditional meter management systems would give us with the readings. We can display the information around charts and graphs and all the things that you would typically be used to seeing here. But from the mobile side, all that information can be pushed to the mobile app as well. So let's say, for instance, I did want to roll trucks to a few of these locations. We store work orders as well as a separate record type that again is tied back into your system. So now over time, we're tying each work order into the location, so you can see a history of how often crews have been there, what meters are there, the readings and things like that before and after crews have visited it. On the mobile, the crews have access to that same information. So not only can they actually see all of the good map-based data here, we have list views of their work orders. So now they can see in a list kind of a normal job jar that's prioritized for them. So they can work from the top to the bottom and prioritize the work kind of as you want to based on your business rules. So for instance, say as a crew, I open up my work for the day and I want to go to this location to start. When I click on it, it's going to snap me right to that location. I can go back to my list. I can get directions to it. So when I click on it, if I hit the directions button, this is going to map me directly to that. I'm already sitting at this one, so it's a 1-minute drive. But now when I flip back to my application, we make sure the crew's workflows are streamlined, just the information they need. So for this one, we've kept it pretty simple. Say they get there and they want to complete the work order. They hit this complete work order button, and we ask them to fill out all the information you'd want. So all of these workflows are 100% configurable to the information you want them to collect. So it can be as simple as just like this, as enter a comment and perhaps take a photo, or it could be as much as, collect the information around a meter you've replaced, get phase readings, all of that. That's possible, but that's 100% configured to your business rules as well. So I'm gonna stop there for now. We just wanted to give you a quick overview of what the platform looks like. And again, please reach out to us if we can do more detailed demos and relate this to your use cases as well. So with that, Mike, I'll turn this back over to you.
Thanks, Dave. That was great. Let me just pull up a slide here and tell folks or remind folks, ask us anything. So we'll jump in and look at your questions there. and I think Madison's going to help me manage the Q&A window. I'll also remind you, you can book your own demo, right? You want to go deeper on your use case, what matters to you, what you care about, because clearly, nobody shares the exact same challenges and opportunities. We're happy to have a personal briefing, talk about the real world of what you're living and what your challenges are, and how and if TerraGo can help you. Um, Without further ado, I will bring up the questions and I will throw them out to our panelists without assigning them. And you guys can please jump in and embellish each other's answers, or you can even correct somebody if you want to. So the first question that we have in here is, does TerraGo support multiple meter types and vendors, or is it designed for a specific AMI platform?
I'll be glad to take that. Historically, we've always configured our platform for what's called a multi-vendor, multi-meter, multi-node environment. We've seen this certainly on the street lighting operation space. It's a trend. In fact, it's probably more predominant than actually choosing one vendor, one alone. In the meter world, there was a time years ago when, of course, you typically have to choose one meter vendor, one full comm stack, and have one head-end system and have some way to stitch that into an MDMM system. Today's MDMs are much more advanced than they used to be, and they can typically handle separate head-end solutions, head-end systems with different meter types. The interesting thing about that, though, is you have all this data, and yet the way sometimes that data is normalized or not normalized in each of the devices can be different. Threshold set in one meter type can be different in the way it presents itself or responds than it is for another meter type. That's certainly true for commercial industrial meters and power quality events compared to residential meters. So we're agnostic to the device manufacturer type. We can integrate with all of them and with the appropriate head-end systems as well. I mentioned earlier about this idea of a smart meter deployment NOC, or that's an interesting approach we're seeing by some utilities doing large deployments where they have all this data crossing around through their system between different meter types, different head-end systems. Head-end systems are feeding into an MDM, but we still can see the data from each head-end system and use that context to drive operational flows. So the data and the billing determinants can still go into one MDM, but below that, through the different head-end systems, we can access that data regardless of the meter type and provide that same type of context that drives operational workflows regardless of the head-end system, regardless of the meter type, because we connect in to see the data flows into and out of each one of those.
Great. Thank you, Charlie. If nothing else to add from the other panelists, I'm going to go to the next question here. Utilities deal with millions of alerts and events. How does TerraGo turn noise into meaningful operation actions like maintenance tasks or decide when to roll a truck?
Well, Jeremy, you'll take that?
Yeah, well, I'll take a little bit of it. You can kind of add on to that. I think
Sure.
so. Part of the discussion that we had, or that we talked about a little earlier, was the flexibility of our platform, right? So the way that we take in those alerts and identify them to ultimately move forward with a truck roll where you need is really through working with each individual utility and understanding your various business rules, right? So as you are looking at your meter data today, you are currently making some form of determination through the data that you're receiving on that voltage is a problem, that information looks a little crazy. And you're making a decision today on whether or not to roll a truck on a set of data. A lot of times that is a very manual process or goes through a number of folks or a number of platforms or a number of decision makers to ultimately get to the point where you're deciding to roll a truck. What TerraGo does is works with each individual utility to understand those business rules and then automate those. So where right now you may go through a manual process or some other form of process to determine to roll a truck that may take hours, days, weeks, whatever that may be, we automate that so that that decision is made within a matter of seconds, minutes, etc. And so that's how we roll through that. So both sides on where to roll a truck, but also by weeding out the noise, right? You're getting all that data. Again, you're making decisions right now on roll a truck or not. And those business rules on when you do not want to roll a truck, we also automate those as well. So those are automatically filtered out. They're saved. If at any point anybody wants to review those, take a look at those, that information is still all captured within TerraGo, et cetera, but it is automatically, for lack of a better term, weeded out and does not roll across anyone's desk as an issue that needs to be addressed. Charlie, I don't know if you want to add to that.
Yeah, well said. I would add just a couple of things. It's often the case in the utility operations where actuating a certain smart device on one end, a smart relay, or as I mentioned earlier, tap changer, anything for voltage support, or recloser operations. If you run reclosers to burn off limbs or squirrels off lines to avoid a truck roll, and when those devices automatically operate, sometimes they don't have the comms to let the utility know they operated. They operate automatically because they're kind of set and forget. And utility sees all of a sudden these other alerts, alarms, momentaries ripple through. Before you roll a truck, oftentimes the issue is, do you have the data in front of you right then to decide, well, don't roll those trucks because that was due to the recloser. The recloser operated, it burned off that limb. We don't need to roll a truck. And then these alerts, all these meters screaming back at you, hey, I just had a voltage sag, I had a momentary, they go away. In some cases, we found devices where alarms or alerts latch, and so they don't self-clear, which is another huge issue because if they don't self-clear, then they still show to be an alarm status when they're really not. So we can take other data from other devices and validate, is that alert, is that condition still present? And many times it's the avoided truck roll that is, well, the worst case is when you roll trucks and no trouble found. That's a huge missed opportunity. It's very expensive to do so. So we try to apply business logic, use other data sources to validate and qualify these alerts and alarms and find out which ones are just noise or caused by some other thing, but there's not an issue at that location. Or the other case we run into a lot, and I know, Jeremy, you've seen this at NextEra, is you roll a truck to the wrong location. You're trying to find an opening point. We're trying to find, is there a cause further upstream? You don't have the data at your fingertips to determine that. So you send a crew, and what the crew does is drive around. They start at the meter and they roll up to the transformer, they roll up to the pole, and they try to find that point. And that takes time. So sometimes it's one truck roll, but it's one truck roll that takes 2 hours. And that's an expensive asset to have on the road driving around with windshield time. So all those things, it's blocking and tackling, but we just found ways to streamline that activity. And it's the avoided truck roll, or it's the truck roll to the right location with the right crew, with the right tools. The other issue we see a lot is you go to a site and you didn't anticipate what you found and you don't have that on your truck. You call and you dispatch a second truck to bring the right equipment or the right crew. So that's two truck rolls where one would really suffice if you have the intelligence. We're trying to provide that filtering and intelligence layer to make this much more efficient. Good question.
Charlie, appreciate it. The next question up is, beyond meters, does TerraGo integrate with other grid sensors or devices to help monitor infrastructure and trigger maintenance activities from those devices?
Answer is yes. Today, I think we showed a slide that showed line sensors, other devices that have data that comes off of them, meters, street lights, etc. We integrate to all of them. Any smart device has some interface, whether it has its own software or whether we can use direct integration into the device to pull data from it. So we use all those sources. And that's one of the strengths of our platform as well. Jeremy mentioned these commercial connectors to your back office systems, but we also have relationships with a number of smart device manufacturers to directly interrogate or get data from their devices. Not waiting for it to ripple through your different systems in a daisy chain approach to find its way to where you can see it, we can get it immediately. And sometimes it's that immediate data. Time is of the essence, where we can see immediately and validate. We just see this issue, go ping that device. Was that device's condition tell us? Is that the cause? Is that part of seeing the same issue or not? And that's one of the benefits we have as well. So imagine this. Every single smart device you have has its own software, its own interface, but you don't want to log into all those interfaces. That's timely. We can abstract that layer out. So really all the data is on one pane of glass. We've done the work to integrate with these devices to pull the data back and present it on one pane of glass so you don't have to.
Great. Thank you, Charlie. We have one final question here, and then we can wrap up. If there are no other questions coming on chat, again, feel free to ask questions. How is TerraGo using AI within the platform today to help utilities improve operations or decision making? Are utilities starting to use AI?
Mike, maybe you or Jeremy can take that one.
Well, Jeremy has the operations expertise, so I'll defer to his finishing off on that. But broadly working with TerraGo's customers, we have an AI core module, and we have a utility down in Texas that used our AI module for detecting assets, detecting from imagery. Oh, this is a pole. These are the attachments. These are the circuit components. These are transformers. So we've used our AI core and applied that to identifying assets and automated asset identification, which is a huge issue, right? For being able to inventory and understand the geospatial location of your assets. Likewise, we also can apply AI to what we would call work order intelligence, being able to say, well, based on these patterns, we predict that your maintenance activities, your inspections should go in this direction, in this sequence, and things like that. Well, again, we work with our customers though, right? So we're not applying AI anywhere they don't want to see it applied. And a lot of times they take a white box view of it, like, let me see what it's suggesting versus my own assessment of this issue and what I want to do. And the other thing we have as part of our platform is agentic AI. It's just an option to be able to go in and ask our platform questions, because with all this data, you can get insights you can't otherwise get, and you can get them quickly, right? So it's the difference we're all seeing today, asking Gemini or ChatGPT a question that's different than a Google search, it's different than looking at a spreadsheet. You can get some inference, and you can say, how often are we seeing this type of issue with this vendor or this type of sensor? And you can get some intelligence that is not obvious from your pre-built dashboards or analytics. So we have an AI core that we can apply in a lot of different ways, and we're doing that with customers today based on where they are, with their AI journey. Jeremy?
Yeah, and I will cover it a little bit differently from the operations standpoint and the support process and some of the AI components that we are including. So, obviously, from the operations and the services standpoint, we on the back end, it's not that we just put the platform in place and then we don't talk to our customers, right? We are a lifetime participant with our customers throughout the life cycle of the platform. And as part of that, right, there are support tickets that come in on a basis that we review. So one of the components that I am utilizing within our team is to extend AI to monitor and identify trends from a support perspective, right? To make sure that we are capturing any trending things that we can certainly get in front of for not only ourselves, but certainly for the customers. Right. So any of those support tickets or questions or calls that come in to my team during the life cycle of the platform, where we are applying the AI component there to capture any known issues that are trending or moving in a certain direction. Again, kind of to get in front of them, or make sure that we are on top of all those things.
Great. All right. Well, thanks, Charlie and Jeremy, and thank you, Mr. Reef, as well for the demonstration. Again, folks, there's an opportunity here to book your own demo. So hopefully there's a lot of value today with our panelists kind of unpacking smart meter operations and what TerraGo's role is in that ecosystem and as we move forward. So again, please feel free to reach out. You can learn more at terragotech.com, and we will send you the slides, and you'll have a recording of this webinar as well. Feel free to reach out to us at any time. Thanks for spending your time with us today.
Thanks, folks.
Good afternoon.
Everybody.